Generative AI is rapidly automating routine cognitive work, drafting reports, writing code, summarizing research. Tasks that used to take hours now take seconds. Because of this speed, the skills we've historically measured and rewarded in higher education, pure knowledge retention and basic software proficiency, are losing their market value. In their place, employers are demanding a new baseline competency. They are looking for the human-in-the-loop evaluator. Evaluators focus on auditing outputs for hidden bias and applying contextual reasoning to catch the subtle errors that algorithms miss. This table maps the change in market demand. It shows a move away from paying for simple content creation toward rewarding evaluative judgment and contextual reasoning. The compensation model of the global economy has pivoted. The premium is no longer on generating content, but on verifying it. Inside the university, the immediate instinct has been to protect the traditional, product-based assessments, like the standard essay, that were built for that older economy. To maintain academic integrity in these assignments, institutions are leaning heavily on AI detection software to scan student submissions. But current detection tools have an error margin of around 12%. That inaccuracy means relying on them risks penalizing students for engaging in the exact kind of genuine human-AI collaboration the workforce now expects. Students left to their own devices often fall victim to the illusion of finality. They see polished AI-generated text and assume it is authoritative, complete, and flawless. When we build walls to keep AI out of the classroom, we remove the very environment where students could practice breaking that illusion. They lose the opportunity to develop disciplined skepticism under expert guidance. By shielding the traditional essay, universities risk producing graduates who lack the critical skills necessary to evaluate and correct AI outputs in the professional world. The solution isn't found in a blanket ban, nor in unrestricted use. We need a situational approach to AI literacy that adapts to different educational goals. The AI assessment scale outlines 5 levels of AI integration. Using this scale shifts assessment focus. Instead of grading only the final product, the educator evaluates the reasoning process itself. But assessing a student's process takes significantly more faculty time than grading a standalone paper. It is a direct trade-off. We have to choose between the highly efficient grading models of the past and the higher friction, relevant assessments required for the future. Level 1 on the scale is the complete absence of AI. This is achieved through highly controlled environments, like invigilated exams or in-person oral defenses. The primary benefit here is certainty. It secures baseline academic integrity and verifies that a student possesses foundational knowledge without any algorithmic interference. The cost is that it is incredibly resource-intensive to police at scale, and more importantly, it is entirely disconnected from how these students will actually work when they leave the university. At the opposite end is Level 5, AI exploration. Here, students and educators actively co-design new ways to apply AI or generate synthetic media to solve complex problems. This tier cultivates the exact skills employers are looking for: the ability to manage and direct advanced AI systems as active co-pilots in knowledge work. But reaching Level 5 is difficult. It demands institutional strategy shifts, extensive faculty training, and a high tolerance for experimental failure in the classroom. The critical tier for true workforce readiness is the messy middle. Level 3, AI collaboration. Students are penalized if they submit unedited, raw AI outputs. They are required to interrogate the AI. They must actively audit the generated text for hallucinations, inherent biases, and cultural blind spots. Forcing them to manually correct the machine's work introduces friction. That friction builds the habits of verification and disciplined skepticism. But this shifts a massive burden onto the faculty. Instructors can no longer just grade a final essay. They have to review the prompts used, the iterative edits made, and the students' reflections on the process. Evaluating a human-in-the-loop process portfolio takes a vast amount of time that is rarely compensated in current academic models. Level 3 produces the exact evaluator skills the economy demands, but it is the most expensive level to operate in terms of faculty labor and institutional resources. To manage trade-offs, this assessment alignment protocol provides a decision tree. Path A targets core foundational knowledge, strictly using Level 1 controlled assessments. Path B targets professional application, moving to levels 3 through 5 to evaluate the workflow process. Across all paths, there is a universal requirement. Institutions must establish clear guidelines for transparent attribution and formal ethical use policies. Purposefully mapping these paths treats AI as thinking material rather than an answer engine. It ensures that even in an automated age, the final accountability for logic and professional ethics rests with the human evaluator. For time-poor faculty teaching massive prerequisite courses, relying on level 1 and 2 assessments is a necessary survival tactic. The resources for deep process grading simply aren't there. But for program directors and upper-level faculty, the people directly responsible for transitioning students into their careers, the calculus has to change. These advanced programs must accept the heavy lift and the friction of process-based grading if they want their degrees to remain relevant to employers. The extra time spent grading prompts, edits, and reflections is the required cost of adapting to an economy that demands critical AI literacy. The professional market no longer pays for the first draft. It pays exclusively for the human judgment that corrects it.